Good afternoon, ladies and gentlemen. Our speaker today is Carol Hill. As a young child, Carol found herself in a house with 0 sisters but 4 brothers, partly because of personality and no doubt partly because of necessity. She became a world-class tomboy. During a family trip to Carlsbad at age 10, the cave fire was ignited in Carol's soul, and ever since that time she has been fascinated by cavers, caving, and caves. Many years from now, I'm certain that part of Carol's legacy will be a magnificent book that she first prepared decades ago called Cave Minerals. Later, with the co-author, Carol expanded the geographic scope of her book, and it is now called Cave Minerals of the World. Besides the obvious scientific value of her publication, Carol is hopeful that the wonderful pictures and explanations in Cave Minerals will encourage even the layman to understand and protect the magnificent wonders under the earth. Carol's interest in the earth is not limited simply to caves. For example, she has done some recent work having to do with her theory on the origin of the Grand Canyon. In the interest of full disclosure, I might add that some of her ideas are not necessarily widely accepted by some of her colleagues, but nevertheless, Carol has had the vision and the courage to relentlessly pursue some theories that may not necessarily be very popular. Thank you for coming today. Please enjoy your afternoon with your 2017 NSS Luminary, Carol Hill.
Thank you all for coming. I recognize a lot of you, but I said, gosh, there's so many old people here now. My husband and I, we've been members of the NSS for we started in 1963. So you can see up there, I'm 8449 and my husband's 7,000 and something. And even our son Larry, who's down here, is under 10,000 somewhere. So we've been around caves for a long time. Anyway, I'll start my talk now. When Dave Hughes asked me to give this luminary talk, I said to myself, what should I talk about? Should I talk about the science? And I thought, no, because there's going to be a lot of cavers there. I need to talk about something that they're more interested in, and a science talk might be really dull and boring for them. So I tried to prepare this talk with you folks in mind, and I thought, really, what to do is to tell stories. So I'm going to tell you 3 stories. The first story here is about the making of cave minerals of the world. Most of you have my book and Paulo Forte's book on cave minerals of the world, so I thought it would be interesting to you folks to give you the history of how cave minerals and cave minerals of the world got started. And then I thought, well, they're going to be down in the Guads. They're all people interested in the Guadalupe mountain caves, and how we came up with a sulfuric-acid hypogene mechanism for the formation of these caves. You all know that our Guadalupe caves are unique in the world, and some of the most beautiful and interesting caves there are. So you're going to hear the story, not just about me, but I want to highlight all the people that have worked on the speleogenesis of the Guadalupe Mountains. So I'm going to highlight other people in that talk. And finally, I'm going to talk about Karsten, the evolution of Grand Canyon. Victor Pollock and I and the Beechers have been working there now for almost 20 years. That seems a long time. We've got out of the Guadalupe Mountains and have been working in the Grand Canyon. And what has happened is we started with the caves, but then we found how the caves are so essential to understanding the evolution of the Grand Canyon. They're the key to understanding the Grand Canyon. So that's the story. That's the third story that I'm going to try to tell. Now, please, no questions till the end. Actually, we have more time at the end than I thought, so you'll have a chance to ask questions at the end. Okay, this talk is dedicated to Will White and Derek Ford, the fathers of American speleology. Now, Derek's not here, but Will is. I just saw him a few minutes ago. And you see, when you see a star by your picture, you're supposed to stand up. So, Will, stand up. Okay. These two men raised up a generation of speleologists for what I consider to be the Golden Age of Speleology. What do I mean by that? It's really when we started to understand caves, and it was due to the mentoring of these two men who had lots of students that we have really the knowledge of speleology, not only in American caves, but around the world. So that's why I wanted to highlight them. And I'm so grateful to both of them for influencing me and being part of this age. So they started it out, and the rest of us are following. So part one is cave minerals. Okay, now for that we have to go back to the Mammoth Cave days here. And Alan and I, that's my husband Alan, and we were very young then, as you can see. 1963 is when we started caving with the Cave Research Foundation in Mammoth Cave. And I'm not sure who took this. I thought it was Art took it, but he said, no, this came before. So Alan and Carol started caving in the Mammoth Cave system in 1963 with the Cave Research Foundation, and that is where we met Will White, Derek Ford, and Art and Peg Palmer, then newlyweds. Can you believe this picture? Look how much hair that Art has. Okay, it is also where I first got interested in the mineralogy of caves and the time when Will White mentored that interest. In 1967, we moved to New Mexico, yay, away from old ugly and into the caves of the Guadalupe Mountains. Now, I had this picture in because I wanted to especially thank Art and Peg, because a lot of the pictures and the diagrams and drawings you're going to see throughout here are ones that Art sent. Okay? All right. The making of cave minerals of the world. On January 18th, 1970, Alan Haar, who's here, I had to go back in old NSS news to get these pictures. Then executive vice president of the NSS invited me to write a chapter in the Caver's Handbook on cave minerals because he knew I'd been collecting articles on speleothems. In his invitational letter, he added, I see this chapter as a fairly complete article on the various speleothems and their theories of formation, which was Al's big mistake, because for those of you who know me, I never write anything short. You know, I have to get it all in. Anyways, here's Al Haar in Bog Meeting 1963, and this happens to be one of Will at the 8th International Congress of Speleology. He probably didn't even know it was taken. Okay, so in the months ahead, with Will White's help in supplying articles, the chapter got progressively longer, thereby presenting the NSS with a dilemma. Should it publish cave minerals as a separate book? By 1972, the Bog response was yes, But there developed a growing internal feud among NSS members about the possible conservation impact of the book. Well, you can see why. You know, you're publishing a book about cave minerals. Isn't that going to bring people in to vandalize them? Would such a book available to the public promote vandalism? Should it be sold at commercial caves or only to NSS members? If cave locations were withheld and a strong conservation message was given, would this offer enough protection? So there was really two sides that were going back and forth and arguing about this. Also, as the book expanded in scope, the cost of publication rose, and the NSS efforts to publish this book began to present numerous difficulties. You can imagine the NSS now, this is their first book. All right. Al Haar, in his 1973 NSS Publications Committee report, explicitly expressed the need for someone to handle the actual publication hassles. Enter Moose Dawson and then BOG member Dwight Deal, both of whom were recruited to deal with these problems. So here is Dwight's response to being assigned to this task here. She's saying, oh no, not cave minerals. Is that right, Dwight? We had a lot of problems, didn't we? Yeah. All worked out, thanks. Finally, but thanks, Dwight, because that started cave minerals and then speleogenesis, and it started kind of the whole process. Okay, finally, after 2 more years of printing cost and other delays, Cave Minerals was sold at the 1976 NSS convention in Morgantown, West Virginia, making it the very first book that the NSS ever published. And here's a picture by Pete Lindsley here of the butterfly in the caverns of Sonora. Okay, so from Cave Minerals, now we go to Cave Minerals of the World, which I published with Paulo Forte. Here's a picture that Alan took of him. We took him down to Carlsbad Caverns. So in its July 26, 1981 BOG meeting, the NSS agreed to publish a revised edition, Cave Minerals of the World. At the 1981 International Congress in Bowling Green, Kentucky, Carol met with Paulo Forte and asked him to be her co-author. Now, if any of you know Paulo, you know how excited he can be. So he was just in seventh heaven, thinking he was going to be the co-author of this book. But little did Paulo know that he would have to do the primary task of covering the non-English speaking world, because I only speak English, and I did a lot of that for the Cave Minerals. Not only that, Cave Minerals of the World was published in Italy, and Paulo had the headache of coordinating with the NSS on cost and details of publication. So he was really involved in the first edition of Cave Minerals of the World. And here's that volume. Most people don't even know of this anymore because it got superseded by the second edition here. Okay? After the first edition of Cave Minerals of the World came out, I was done with the book, but not Paulo. He wanted a full color book, one completely updated with regard to minerals and references. And that was me, references, 5,000 or so references. So I agreed to one more edition, the most thoroughly professional and definitive work ever written on cave minerals. Now that sounds like a bragging, but of course it was the only book, so it was the best. Okay, now here is Cave Minerals of the World, came out just in time for the 1997 12th International Congress of Speleology in Switzerland, where it won the Best Book Award. And here Paulo and I were signing books, but what's not shown is a whole line behind us of about 15 other co-authors that had written special sessions. So it started with me, and it just went down a whole line of people there that had contributed to the book. Okay, in the introduction to this second edition, we made the following statement. 20 years ago, when the first cave minerals came out, all who were connected with the book were worried about whether its publication might provoke vandalism. Happily, the publication of this and then the later cave minerals of the world did not increase vandalism, but actually educated the caver public as to how precious and beautiful cave minerals are when they remain in their natural state. Cave minerals belong in and should stay in caves. So we got that across, and I think we mainly got it across to the NSS type cavers, but that whole attitude was then perpetuated down to other cavers. So Paulo and I, after this, we felt we'd done our job, what we set out to do years ago, and we were done. It says, note, there will be no third edition of Cave Minerals in the World by Hale and Forte. And I know that's the case because I packed up 4 boxes of articles on speleothems, and all my cave mineral stuff went to California and Bologna to the institute there, and to be used by anybody in the world to come in. Also, a number of samples I had collected so other people wouldn't have to collect more samples and could use what we were doing. So that's the end of cave minerals story. So I abandoned the topic of cave minerals. The reason being that I was already heavily involved with the sulfuric-acid hypogene speleogenesis of Guadalupe Caves, and I wanted to devote my time to that effort. So I went from cave minerals to speleogenesis. So here, this logically follows from cave minerals to part 2, history of speleogenesis of Guadalupe Caves. And that's something, if you're a Southwest cave or whatever, you know what that's all about. But some of you don't. It's essentially this hypogene sulfuric acid mechanism. We were some of the very first people to show that this operated in a cave system, and why the Guadalupe Caves were so different than other caves in the world. Now there's maybe, I'd say 95% of the caves are still carbonic caves, but you have a small percent that are now being recognized as being hypogene type caves. Okay. Oh, wait a minute. Or how the evolution of a new idea often involves many people. So in this next section, some of you are going to be asked to stand up because you were really active participants in making this idea of a sulfuric acid speleogenesis, carrying it to where it is now, which is really in the forefront of speleology. Okay, here we're going to start. Here, history of speleogenesis of Guadalupe Caves. We're going to start with the Guadalupe Cave Survey, GCS. And there's 2 people in here that helped found the GCS. And you see, you got stars by your pictures. Can you please stand up? Pete Lindsley and John Corcoran. Can you stand up? One there and one over the other side. Okay, Pete Lindsley here and John Corcoran here, who founded the Guadalupe Survey in 1965. In 1966, the GCS found the Guadalupe room. It wasn't even known till then. GCS provided the organization and interfacing with the National Park Service that was necessary for ongoing scientific work in Carlsbad Caverns. That's really important, isn't it? You better get along with the people that you're, whose caves you're working for. And we were lucky, because at that time, then Superintendent Phil Van Cleve was instrumental to founding this effort, and NPS involvement continued with Larry Henderson. Now, I don't know how it's continued since then, but those two men were so interested in research. Once Cindy Moshe and I were up in one part of the cave, and Phil Van Cleve, I think we were in the New Mexico, we came out and he was walking down the trail, and he said, "I hear you found sulfur last night," or whatever, in the caves. I mean, that's how interested the National Park Service superintendents were when we started out with this research. Okay, okay, all right. Principal people involved in early geologic investigations of Carlsbad. In 1971, Carol Hill, Dave Yagna, Harvey Duchesne, and Dwight Deal, then all graduate students at UNM Geology Department, started the geologic investigation of Carlsbad in the mystery room area of the cave. When we started out, we didn't have a clue as to why Carlsbad was so different from Mammoth and most other caves. And while we were in the mystery room, I still have the notes of that. We just BS'd back and forth. We didn't know what we were saying at all. You know, coming from Mammoth and stuff, this was so different. We just, it was just mind-blowing. The whole process of a new sulfuric acid mechanism took many years to figure out, each discovery building on other prior clues. And that's why we're going to start at the beginning. You're going to find out the history of who did what. So again, this is Donald Davis, Michael Queen, Carol Hill, Dave Yagna. Now, this picture was actually taken by Ron Kerbel on the post-convention, post-Congress field trip, the Bowling Green field trip. Oh, wait a minute. This picture of Harvey here, this was taken in 1967, but not too long afterwards, he went in the Navy. So I'm just going to say, we're going to come back to Harv later, because when he came back, he did a lot of other work. So here's the story. Also in 1971, Stephen Egemeyer was the first to propose that Carlsbad Caverns may have been discovered by sulfuric acid, based on the work he was doing for his PhD dissertation in Cane Caves in Wyoming. He visited Carlsbad in 1971 and suggested this origin in a report to Carlsbad Caverns National Park, a report that was subsequently lost and never found again. Somebody just took it out, I guess. He completed his PhD in 1973, but unfortunately died soon after. Now we're going to go to Donald Davis. You all know Donald, who had caved in the Guadalupe Mountains since 1960, and who had also caved in the Cane Caves, saw Egemeyer's report to Carlsbad Caverns National Park and began considering a sulfuric acid speleogenesis for Guad Caves. He suggested that the native sulfur in cottonwood, here's the native sulfur, was evidence of a hydrocarbon connection to the Delaware Basin, with the H2S being generated from reactions of hydrocarbons with gypsum and hydrate of the Castile Formation in the basin. He published that in 1973. Now this shows sulfur in cottonwood. I think that was the only case of sulfur being known in the Guadalupe Mountains at that time. So, but for you that don't realize, having sulfur in the cave is not ordinary. You'll never find them in any eastern caves or whatever, because this mineralization can only come from like hydrogen sulfide, which is leaking into the system, and that implies hydrocarbons. Right. All right, here we're going to highlight two guys, David Yagna and J. Michael Queen. I'm not sure if Dave's here. I heard he was here yesterday. Dave, are you here? Anyway, okay. And Michael Queen, where are you, Mike? Are you here? You're not here? I saw you earlier. Okay. In 1971 to 1973, Dave Yagna began his field work in the Guadalupes for his master's thesis. Dave had caved in Iowa, where many iron ore bodies were related to cave formation. So, like, if you've been in the Queen of the Guadalupes, that's an example of where you have an iron body and a cave below it. So Dave proposed a similar mechanism for Guad caves. The sulfuric acid had come from pyrite. Dave published his master's thesis in 1977. This is some pyrite above Cottonwood Cave, and if you've been there, that part of the Capitan limestone has a lot of pyrite in it. So that was what he was basing his theory on. Okay, in 1973, Michael Queen produced the first strong evidence that gypsum had replaced limestone in the caves of the Guadalupes. He published his brine mixing model in 1977. Queen's ideas for Guad caves are similar to how seacoast caves form. So you can see there was a whole lot of theories here about what was happening. Now here, and actually Mike's work was very important, and it explained things like, here's a dry cave, the replacement gypsum. Now for those of you who are not too familiar with mineralogy of the cave, replacement gypsum is not the same as speleothemic gypsum. Like you can go in Mammoth Cave and see gypsum crust, or Watts Cave and see gypsum crust. These are not gypsum crust. They're an actually replacement of the limestone by the reaction of sulfuric acid on limestone goes to gypsum. That explains the big gypsum blocks in these caves, and also the wall rocks. So here, this shows it. These, you can't see it too well in this picture, but these are called piezolites. Piezolites are pea-shaped concretions that form in a back tidal setting like the back reef, so forth. And you can see them at the entrance of Carlsbad too. But you see here, this gypsum now has the piezolites in it, because it was once up here. This whole block was once up here and then slipped down. So that was really important, because speleothemic gypsum is not going to have replacement textures in it. Right? Okay. From this early history, you can see that a sulfuric acid cave model with different interpretations as to how it had operated emerged about the same time, 1971 to 1973. Once this idea was out, then people started explaining it different ways. This often happens in science. An idea maturates until a number of people propose it at almost the same time. It happens in all fields of science. It's called synchronism. So what was I doing in 1971 and 73? I was working on the mineralogy of Carlsbad Caverns for my book, first edition, Cave Minerals. In the course of this investigation, I came across the mineral endolite. and found that this waxy mineral formed in low pH sulfuric acid solution. So here essentially I collected, this is in Endless Cave, but I collected waxy material in Carlsbad, did an x-ray on it, found out what it was, and got into the literature and found it only forms in pHs of about 3 or below. So that light bulb went on my mind, up in my mind, because that said, well, Egemeyer and Davis, sulfuric acid, that would explain this presence of this mineral. The data fit with the sulfuric acid mechanism proposed by Egemeyer and Davis. So in 1979, I collected a sample of cave gypsum from the big room and had a sulfur isotope analysis done on it. Now, for those of you who don't know much about geology, sulfur isotopes are not radioactive isotopes. They're called stable isotopes. But the value was minus 15 per mil, which meant it had to be related to H2S generated in the basin from hydrocarbons. I can't go and explain why, but essentially this is the Castile Formation, the marine evaporite deposit out in the basin. This can't come from this. You have to have hydrocarbon reactions. I presented my first isotope results at the 1981 International Congress in Bowling Green, Kentucky, and this is a graph that I showed, but this X here was the very first one, minus 15 per mil. So, I published my Geology of Carlsbad Caverns book in 1987 with the New Mexico Bureau of Mines. It's now the New Mexico Bureau of Geology. This book is no longer in print. I also published the cover article in the AAP Bulletin in 1990. Here, this Lake of the Clouds photo was taken by Dave Yagna. And the reason the AAPG asked me to write this article in the bulletin was because I was saying these caves are related to hydrocarbons. So AAPG is a petroleum geologist bulletin, so that's why they were interested. Okay? Now we're going to go to some other people. And I don't know, Victor, are you here? Where's Victor? Anyway, I know Paula's working with the JSS. So at any rate, Victor started studying dripstones and flowstones in Guadalupe in 1986. He then began to examine clay minerals in Guadalupe caves in 1960. Publishing a paper on alunite and halloysite in 1996 in caves and clays and clay minerals that relate to the sulfuric acid origin and age of the Guadalupe caves. Now this is Paula here. Paula is we're in a Grand Canyon cave here. She's studying the dripstone, looking at dripstone, but I just wanted to point out all the breccia in the ceiling. This is part of the Mississippian paleokarst in Guadalupe in Grand Canyon caves, and it's one reason the caves are in the Mooney Falls member. Those are the caves we've been studying because way back in Mississippian time, it set up permeability so the water in later times could go preferentially through that horizon. Okay, here's Paula in the Grand Canyon cave. Note the paleokarst breccia in the cave ceiling in the upper right when cave passages typically cut across Mississippian paleokarst. Paula is the UNM Geology Department's electron microscopist and material science specialist, and has used SEM, TEM, EDS, lots of things on both our Guadalupe and Grand Canyon samples. And she's co-author of, I think, 3 papers that we've written on Grand Canyon caves because she does all our microscopy work. Okay, and this, they got a picture on the cover of Geology here. This is of a mite encased in flowstone and hidden cave. Well, okay, Victor, my colleague Victor. Okay, here's Victor. This was before we started in the Grand Canyon. Here's Victor collecting alunite from the clay for the big room. And I took his picture there. That started our collaboration. That's now over 20 years we've been collaborating. Victor is responsible for determining how old Carlsbad and other hypogene caves in the Guadalupe Mountains are. He did this by using the potassium-argon method on alunite. This is the formula, but you have enough potassium here to be dated. Victor published his results in Science in 1998. The Big Room lower cave levels of Carlsbad dissolved about 4 million years ago, and caves higher in the Guadalupes are even older. So here's Victor's data points here, and this is how he projects how the water table lowered. Way up here in the high Guads, like Cottonwood and Virgin Cave, they're about 12 million years old, and these down here, Lechuguilla, the lower levels and stuff, are about 4 million years, and here's where the current water table is. Now I want you to kind of remember this graph, because we're going to get to another slide in a little bit of Harvey Duchesne's saying how this affected the water flow through the Guads. Okay. Oh, Victor was given the NSS Science Award in 2015 for his dating and speleothem work, and his work has been absolutely essential to our work in the Grand Canyon, because we've been dating mammillaries in the Grand Canyon. I'll tell you about that in just a minute. Okay, now let's see. So Victor is not here? Okay, well, he was supposed to stand up and Paula too. Okay, Art and Peg Palmer. Okay, I see 2 stars right here. Can you stand up? You too. All right. Art and Peg started mapping the levels of Mammoth Cave in the late 1960s. That's when we met them, and in Floyd Collins Crystal Cave. In 1989, they began working on Hypogene Karsten Lechuguilla Cave. In 1991, Art wrote a seminal paper in the GSA Bulletin, Origin and Morphology of Limestone Caves, which won the prestigious Kurt Bryan Award. Art's last article was one of the first to be published in a major geological journal. It helped a speleologist pass the dirty caver syndrome. I think his was one of the first in a major journal. Art and Peg helped with the book. Art, with Peg's help, wrote the book Cave Geology in 2007, and together they edited the book here of Caves and Karst of the USA in 2009. I can hardly see over here. 9, I think it is. The concepts of Hypogene Karst that they learned from working in Lechuguilla Cave are covered in both books. So you see, by that time, now things were getting a lot more mature. We were understanding all different aspects of the Hypogene model. It was evolving. Okay? Now, here's Harvey Duchesne. He's back, and he has to stand up because there's a star there. Where are you, Harv? I know you're. Oh, there it is. Okay, so Harvey is a petroleum geologist, so obviously he's going to try to connect the caves with petroleum. So Harvey Duchesne, working with USGS petroleum geologist Kim Cunningham, proposed a speleogenesis model for integrating the hypogene sulfuric acid theory with regional petroleum geology and tectonic uplift of the Guadalupe Mountains. extensional faulting starting at 20 million years during the Basin and Range. That's the age that the Basin and Range pretty much started. Fragmented the east flank of the Oligocene Alvarado Ridge here, allowing fresh water into Guadalupean strata, which caused the biodegradation of petroleum, thus generating copious quantities of H2S that ascended into the reef to form the last sulfuric acid episode of cave formation in the Grot. Essentially what we're talking about, here's the Basin and Range. We're in the Basin and Range here, right? We've got 20,000 feet of displacement along the Sandia Fault here. So this is the fault of the Basin and Range. Here's Guadalupe Peak, and you can see here, I compare that with what Victor did, the caves up here about 12 million years ago, and the water table dropped, and you've got the water table now below the caves. Whoops. Missing Harvey here. Harvey Duchesne was the leader of the Geologic Mineralogy project from 1901 to 1998, and here he's noting a gypsum block in Lech, and here's Har recording many speleothem types in another room in Lech. So the park got an inventory of a lot of its speleothems. Diana, Northrop, and Penny, Boston. Here's 2 stars. Okay, yay. Now, they're microbiologists, but look, you've got geomicrobiologists here. One thing leads to another and another, and that's how things work in science. 1971, we sat in the mystery room, and we didn't know what was happening at all. We didn't have a clue. And now, these gals, I mean, their work still goes on, but they're in the forefront of finding whole new species of very primitive bacteria and so forth. So you see how one thing leads to another. You can't tell in science which way it's going. Right? Here's Diana Northrop and Penny Boston collecting microbial samples in Hypogene Cave. They began their work together in Guad Caves in 1994 and still work today. Right, gals? Kind of, yeah. All right, this is corrosion residue in Hypogene. Corrosion residues remain on the cave walls and ceilings after the carbonate fraction had been dissolved away. It is mostly in this residue that microbes reside. Here's condensation corrosion in Spider Cave, a cave not far from Carlsbad. Airflow from the entrance scours the cave walls. These are the main areas of corrosion residues and microbial activity. And just recently, Bob Beecher reminded me of the first trip I took into Spider Cave. I couldn't believe it. I said, these look like they've been sandblasted. I mean, well, they have, kind of, because the wind comes in and just condensation corrosion just dissolves the cave wall. So we really started thinking about things like the Shields and Lehman caves are out in the middle of the floor. The walls are actually dissolving away by condensation corrosion. So it gave us a whole different picture of how cave passages can widen after the water's out. And here's the girls' model here of what's happening. This is bedrock here, just regular old bedrock. On the surface here, you see these are the buggies right here, manganese bacteria and iron bacteria, because they're finding iron and manganese in the walls, so the bugs are going to eat them. Oh, Mike, okay, too. You should have stood up too, Mike. At any rate, so in here, you see how this corrosion residue the first time I really looked at that, Alan and I were in the Belcord room just up from the Lake of the Clouds. And I said, Alan, look at this. And I stuck my finger practically all the way into the wall. And I said, boy, is this rock punky. And so this word punk rock, I have it in my book in Carlsbad. So everybody started calling it punk rock. Okay, we're to part 3 here now. I'm going to get a little drink of water. So, we're into Karsten, the evolution of Grand Canyon. Like I say, very few geologists believe in Karsten, the Grand Canyon, but it is the cause of a lot of the cause of where the Colorado River goes, and the whole evolution is tied up with karst. And we don't have too much time for this. Okay, my work in the Guads ended in 1996 publication of my Geology of the Delaware Basin book by the Permian Basin sections of the SEPM. After persuading Victor to join me in a new karst project, we were off to the Grand Canyon before we got too old to work there. I mean, we were starting to get up, so we had to very carefully make our plans for the Grand Canyon. We have to go to the hardest caves first. We have to do the most strenuous stuff. And then when we get old, we'll get on the top, on the Guadalupe Plateau and stuff like that. The insight, let's see, that was almost 20 years ago. We started our Grand Canyon project in late 1998. Okay, the insight to work in Grand Canyon caves came from a trip that my husband Alan and son Roy, who was then 16, now he's 51, and I took to Bada Cave in 1982 to observe the speleothems as per a National Park Service requested us to go down and check those out. The sequence of cave deposits exposed in the entrance room of Bada led me to suspect that these deposits might be the only record of water table lowering and age of canyon incision in Grand Canyon. It was then that I decided to come back someday after I was done in the Guads. Okay, why would it be a record of water table lowering? Because I'd worked in the Guadalupe Mountains before I came here, and I knew all about gypsum rinds and this and that, and that mammillary speleothems formed at the water table and so forth. Okay, now we're in the Grand Canyon. There are two main ways in which karst deposits and processes relate to the evolution of Grand Canyon, and both of these are very important. Water table speleothem dates from absolute dates where the water table was when can be determined on the entire length of the Grand Canyon. So what we did was on one river trip and lots of other trips, we went from the Lee's Ferry, started into Marble Canyon, those caves, and we collected samples all along the Grand Canyon in caves to see, okay, how old are these and how old are these and where was the water table when? Okay. This allows for estimating rates of incision for different sections of the canyon, and Victor and the rest of us here wrote 2008 article in Science. Okay. Karst piracy. How did the Colorado River cross the topographically high Kaibab Arch and turn west? What am I talking about? Here's Colorado, here's the water coming from Colorado, and here's the Kaibab Arch. That's the high point. Jacobs Lake, like right here, is at 9,000 feet around. So here we come. So wouldn't you expect that river to go on this side of the canyon and just keep heading south? Why in the world would it cross the highest point in the whole Grand Canyon area and turn to the west and take these routes through? So that was noted by John Wesley Powell when he first went through. How come this turns west in the high part? Okay, we, that is Victor and I, proposed that it went under the arch by the process of karst piracy, where streams are pirated under a topographic divide along a soluble rock horizon like limestone. Okay, here's a map of the Grand Canyon. Now this is where Victor and I proposed at the area of karst connection. It was on this side and somehow it went under the Kaibab Arch to go and follow the route here. And by the way, this whole route here, this is other work we've done, this was set up a long time ago. Some of these canyon parts in here were set up as long ago as 85 million years. So the Grand Canyon is older than 6 million years. Okay, now here's our I can't see it even. Our core Grand Canyon research group. You can't see that very well, sorry. This is Victor, this is I, this is Bob and Deb Beecher. Over the last 18 plus years, we have been all over this area. We have been north, south, east, and west on Colorado River trips and over plateaus. Over the last 9 years, we have worked mainly on the Coconino Plateau and Kaibab Plateau, which work has involved the age and evolution of the entire Grand Canyon. So we started out to only look at the caves and see the karst hydrology, and then we have ended up trying to put pieces together to talk about the evolution of the entire Grand Canyon. Now, what kind of caves are in the Grand Canyon? Vadose caves and phreatic or hypogene caves. These are just normal caves where water comes down. It comes down to the Moab limestone at its base, and then it moves along the top of the Bright Angel Shale, because the Bright Angel Shale is an aquiclude. That means the water doesn't go down, and then it comes out and it enters and exits in waterfalls like Tapeats or Roaring Springs. If you hike the Grand Canyon, those are all vadose caves. We haven't even been to the vadose caves because they really don't tell us anything. We want to know about the past. That's just kind of present day hydrology. What we were studying is the Hypogene Caves. Most Hypogene Caves are located in the top Mooney Fall members of the Red Wall Limestone. The Hypogene Caves are confined beneath Supai sandstones and following along a Mississippi age paleokarst horizon. Okay, why isn't it going? It won't let me go because I'm over. Your battery is very low, it says. All right, maybe I go this. Nope. It won't let me go. It says my battery is low. Some reason. What? Yeah. Close. Okay, let me close, so maybe we can go forward now. No. Just do that. Okay, I tried that, so I closed it. So now we're out of this, I guess, and right here.
Yes.
Okay. Oh, yeah, right. All right, sorry. Now, deposits exposed in Grand Canyon caves. Hello? Okay. Oh, that's off too? Hello? No, we got it. All right. So this is actually where I first saw in the entrance room of Bedah Cave, these sequence of events that I had learned enough in Carlsbad and working in Guadalupe caves to realize how important this was. Sequence of deposits exposed in the walls of Bedah Cave. First is bedrock, then was hematite and girthite. Then you had calcite spar linings, then you had mammillaries. Bedah Cave displays all of these episodes. Other caves may display only 1 or 2 episodes, but these episodes are always in the same order, denoting progressive descent of the water table. That's really important, that in all the caves, you might just have a few, but they always go by this same sequence. So that sequence is telling us what was happening over time, right? We aren't going to go into this except to say hypogene fluids are interacting with epigene fluids and causing mixture corrosion. That's depositing the hematite in cavities within the red wall limestone. And this is one of Victor's photos here showing hematite and calcite spar overlying the hematite here. And this is just to show there's only 2 of these in this particular cave, but still this is always on top of this. Okay? Cave episodes. Cave passages dissolve. Then you have calcite spar. Then you have mammillaries, and they're going to cut me out. I've gone over my time, I know, but you said we had a little more time. Yeah. Okay. Anyway, if you know anything about the solubility of calcite, you actually get more soluble as you get cooler, whatever. But anyway, the first thing is the cave passages dissolve. Here's a cave passages. This is a spar, and then the spar overlines the cave. And this is the spar lining in a Wallapai cave on the Wallapai Plateau. So first comes the dissolution of the cave passage, then comes the spar that's lining it. And then as the water table descends, you're getting mammillary formation just above the water table. It's like in Guadalupe caves. So the mammillaries, if you date the mammillaries, you know where the water table was. That's the key idea. Then as you get right down to right at the water table, you get things like folia and cave rafts and so forth. And then just above, you're getting gypsum rind, just like in Guadalupe caves. And I think we got a sulfur isotope of -8 per mil or whatever, so it was due to hydrocarbons here too. So here's a mammillary line, Eastern Grand Canyon Cave. These speleothems form just below the water table. These we date right here. Here's folia in an Eastern Grand Canyon Cave. These speleothems form at the water table. Gypsum rind, Cave of the Domes. Gypsum rinds form just above the water table, just like, okay, so you see the sequence of events makes sense when you say, okay, you're way deeper here and your caves form and then far and so forth forms. So the continuous process. So by understanding this and dating the mammillaries, we were able to tell from one end of the canyon to the other where the water table was. Back when. Okay, so here's the idea of the lowering of the water table. Here's the water table way up. You form your cave and you form your spar. Then you form your mammillaries right at the water table here. And then you form gypsum rind just above the water table. And then you have your dripstone. Okay. The importance of this work is that since mammillary speleothems form near the water table, by uranium lead dating these deposits, we are able to trace the approximate descent of the water table over time and place throughout the canyon. This allowed us to estimate incision rates and ages for different sections of the canyon, and from these dates we proposed that there was a 17 to 6 million year pre-Colorado River Western Grand Canyon that was older than the 6 million years Eastern Grand Canyon. Okay, our Pollock et al. Science paper was considered heresy and rejected by Grand Canyon researchers because they all knew that the Grand Canyon was only 6 million years old. They had known it for about 70 years, and anyone who said any different, you see, then the tourists are all mixed up. You tell them, no, it's you got an older part of the canyon. Well, now I don't know what they tell them, because our work and other people's work, the canyon goes back to about 80, 85 million, certain parts of it. This attitude has changed over the last 8 years. Now most Grand Canyon researchers, including us, believe that the age of the first sections of the canyon go back to about 85 to 80 million years, and we just published a paper on that last year in Tectonics. Wait a minute, get confused here. All right, here's the last part. A karst connection under the Kaibab Arch at 6 million years. Remember, that river's coming down, and why does it go under the arch? Well, it's called karst piracy, and it happens all over the world. For any of you karst people who've been different parts of the world, this is nothing new, but it's new to geologists who don't know anything about karst. Okay, here just briefly, stage A, you have to have a steep hydraulic gradient must exist between two sides of uplift, and high permeability rock, that's the red wall limestone, must be able to transport water between them. Stage B, leakage starts to occur under this topographic high. So you start having leakage, and it starts making small cave passages and so forth. And it exits in springs, and then you have headward erosion from the springs. Okay. Stage C, the river is now going completely under the arch and diverted. It's diverted underground. This would be the Colorado River about 6 million years ago. D, here's unroofing here. The unroofing and karst windows eventually form a narrow gorge, and here's the narrow gorge widens into a canyon. So there's no evidence for that cave or cave piracy. It's gone because this whole process is about 6 million years old and the canyon is widened. Okay, does karst piracy happen in the real world? Yes, and some of you people have been in China or whatever, you know that it happens. Okay, this is a drawing of the Swabian Alb in Germany, and it's supposed to be stage C here. Here's the Blue Danube. It's going to the Black Sea here, but part of it's captured in the sinks, goes under, exit at the Ox Spring, and goes all the way to the North Sea. Do you see what we're proposing for the Grand Canyon? It's going south, it's captured, and it goes under the arch, and that connects the east and western Grand Canyon. Okay, here's a South China karst. This would be stage D. Unroofing in these karst windows forms narrow gorges, and this would be a window, karst window, and this is a cave. All right, we're just about done. I just want to give special thanks here to Bob and Deb Beecher, who have been with Victor and I for 20 years. They knew all about where all the caves in the canyon were, so they were essentially our guides. So they get to stand up. Come on, Bob and Deb. Folks, we couldn't have done our Grand Canyon work without them. And here's one of Bob's pictures here. I think that must be Deb, because he always finished karst talks with a view like this of a cave entrance, right? Okay, Now for the most important person. To my husband, Alan, who has put up with me for 57 years. He gets to, come on, you have to stand up. Yeah. All right. Now, I thought I'd end with this picture. I found this also in old NSS News. Here, this is Allen Hill. In a 1969 bog meeting in the then new Huntsville headquarters. I'm not talking about the one that was just here now. I'm talking about the one that went way on back. Look at these guys. White shirts and ties. Can you believe this? Is that what the bog meeting looks like now? I don't think so. And here on the left is Russ Gurney. And he's one of the people that started the NSS. And this is Alan here before he even had a beard. So it's a long time ago here. So that ends my talk. And I want, they said we had some time for questions, right? Or did I go too long? Okay. So I guess, anybody have questions? Did that kind of overwhelm? We went back, what, 30, I don't know, 50 years in this talk. Well, thank you. Thank you. There weren't too many of us back then. Not too many, but thank you very much, and enjoy the rest of your day.